welcome you all in my amazing channel, Mr. MBBS. I leave no stone unturned to quench your thirst of knowledge. So please subscribe my channel and get joined to my family. You know my channel is still newborn baby, so I hope you'll support it and help it to grow. Well, let's move on. So I'm back with one more uses of dimensional formula. This is the last and final use of dimensional formula, that is to derive the relationship between different physical quantities. So for example, let's take one equation of centripetal force, that is F equals to mv square upon r. So for a while, let's forget this relation. We are going to derive it dimensionally. So for a while, we don't know whether these quantities, physical quantities given in this equation, are directly proportional to each other or inversely proportional to each other. For a while, we don't know that. Okay, we don't know about the relation of its powers. So dimensional formula deals about powers. We know that. What is dimensional formula? Dimensional formula is the powers raised over the fundamental quantities, isn't it? So here, let's see in rough. So we have one equation here of centripetal force. We are going to derive these today. So let F is directly proportional to m to the power a, b to the power b, and r to the power c. Let this be equation 1. We are going to derive this equation. Okay, so when you remove this proportional sign, then we get equals to over here and a proportionality constant, isn't it? We get this proportionality constant, and remember, this constant is dimensionless. So we are not going to deal here with this. We are going to see this term and this here. Now what we will do is we will write up all the dimension of these quantities given in both sides, that is LHS and RHS, and we'll see what can be done further. So let's write the dimension first. So we have remembered the dimension of force. If you don't know, then go and check my videos. Right, type unit and dimension Mission MBBS, you'll get that video and learn how to make the dimensional formula. There I have dealt with all these things. So here we will directly write the dimensional formula. So dimensional formula of force is mlt to the power minus 2 inside the big bracket, isn't it? Now here we will not write the dimensional formula of k, it is dimensionless. Well, the dimension of mass is m, power will be 1, isn't it? And this a will be as it is. Similarly, velocity will write lt to the power minus 1, and this b as it is. This is dimension of velocity. And r, it will be l, length, it will also be power 1, and c as it is. Is it okay? So from here we can equate the powers, isn't it? Here also it is 1, and it is minus 2. Here it is this. We can write this as m power a, l power b, t to the power minus b, and l to the power c, isn't it? Now this becomes what? This becomes m to the power a. There are two l, so l will be b plus c and t will be minus b. So this we get, isn't it? Now we'll equate the powers, and by equating the powers, you write it the language yourself. By equating power, what we get is a equals to 1, b plus c equals to 1, and minus b equals to minus 2. Minus will be cancelled, and b equals to 2. Now we know the value of b, we put it here, and we get the value of c, isn't it? C equals to what? Minus 1. Put here value of b, it will be 2. 2 will go here, it will be minus 2, and minus 2 and 1, it will be minus 1, isn't it? So value we get a 1, c minus 1 and b. Now putting the value in equation 2 we get, now putting this value in equation 2 we get f equals to k m to the power 1 b to the power 2 and r to the power minus 1. As it is ABC, we put this ABC value here, we get this. We can write this like k mv square, and this minus 1 it will go down, it will be r. Now experimentally value of k is found 1. See, dimensionally we cannot determine what is the value of proportionality constant, but experimentally it is found 1, so we'll write 1 here. So this is one drawback of dimensional formula, we'll talk it in detail later. So here we'll write 1. Whether we write 1 or not, it does not matter, isn't it? So this is our relation, that is f equals to m v square upon r. This is what we are trying to derive, and we got this. In this way you can derive the relation between different physical quantities. So this is our final use. Now let's talk about the limitations. Limitations of dimensional analysis. So let's see this also in raw first. In this equation here, this time period of simple pendulum t equals 2 pi root under L by g. In this constant, see this constant 2 pi. Whether we write 2 pi or we write 4 pi, this dimensional analysis cannot detect it, cannot correct it. We do not deal with this constant in this dimensional analysis. So this is one drawback. Now not only the dimensional constant, even the trigonometric functions used in the equation cannot be derived from this dimensional analysis. So in this magnetic flux density we have sine theta, so this cannot be derived by this dimensional analysis. This is also one drawback, one limitation of dimensional analysis. Another is that it fails to derive the relation if the physical quantity depend upon more than 3-dimensional quantity. Now if we have mlt in terms of mlt in 3-dimensional quantity, it's okay, it can be derived, but more than this cannot be derived. So this is another limitation of dimensional analysis. Now the dimensional method cannot be used to derive the relation other than the product of power of the function. Like in the example here, we have in form of product of the powers, isn't it? Multiply or divide, then we can derive this relation using dimensional formula. But in case of this formula, suppose if you write v square equals to u square plus 2as, so in this case we cannot determine whether it will be plus or minus in between by using a dimensional analysis. So this type of equation can also not be derived dimensionally. So this is another limitation of dimensional analysis. Okay, another limitation of dimensional formula is that it cannot say whether a physical quantity is a scalar or a vector. Now a scalar has only magnitude, vector has more magnitude and direction, but here we cannot determine dimensionally whether a quantity is a scalar or vector. So these are the limitation. Let's go once more. Here we can see dimensional constant cannot be obtained using dimensional analysis. As we have seen here in the example, dimensionless constant cannot be obtained using dimensional analysis. Now physical relation involving exponential, trigonometric function and logarithmic function. The one equation which has log, we have seen log in different equation. Similarly, I have shown you the example of sine theta. So that and exponential, these cannot be derived by using the dimensional formula. Similarly, more than 3 physical quantity dimensional formula can also not be derived. And there is, we cannot determine the plus or minus in between the equation, and so this can also not be determined. Dimensional method cannot be used to derive the relation other than product of the power function. For example, this cannot be derived by using dimensions. And there is, it cannot determine whether it is scalar or vector. So that's all about the limitation of dimensional formula. So thank you for watching. Now you can take the screenshot and make your note on your own. Thank you very much.